Okay, Bismillah ar-Rahman ar-Rahim. Okay, gentlemen. We will do a review first, and then we continue with the series parallel networks, okay? So the title of the chapter, it is chapter number 7, okay? Series parallel networks, okay? Let's do a review, okay? Series network or series circuit. What you know about series circuits, gentlemen? You know that you have a power supply with resistances in series. Let's say RA, RB. Okay? So what you know about this circuit is that this is IS, R total equal RA plus RB. Okay? IS equals E divided by R total. And VA equals, using the voltage divider rule, is equal to RA divided by R total times E. Yes? Huh? This is what we have learned in series connections. Okay? Let's see for parallel connections. Okay? We have here RA, RB, E, IS. What you know about parallel circuits, gentlemen? R total equals RA in parallel with RB. Yes? And you know how to calculate, okay? The total resistance for parallel connections, okay? Of course, it is 1 over RA plus 1 over RB. And IS equals E divided by R total. And VA equals E. VB equals also E, because they are in parallel with the power supply. And by using the current divider rule, we can determine IA. If we want to determine IA using the current divider rule, it is R total divided by RA times IS. This is by using the current divider rule. Or we can use the Ohm's law. IA equals E divided by RA. So this is about series connections and parallel connections. Do you have any question? Huh? So you mastered this topic, okay? So now we are going to combine series connections with parallel connections. We call it series parallel networks, okay? So I will remove this part, okay? And then start talking about the series parallel networks. Can I? Yeah. Can take pictures. Yeah, it will be in the YouTube. Yeah. There will be different sessions recorded, and you will have access to YouTube. Okay. It's okay? Let's see how we are going to solve problems where we have series parallel networks, okay? Let's consider this problem, or this circuit. R1, R2, R3, and R4. Okay? And it is required to determine I2 and V4. So how to solve this problem? It is not series network. It is not parallel network. It is combination, series and parallel network. Okay. So we have two approaches. We reduce the circuit into a simple circuit. Okay. Then we return the circuit, or we use the block diagram approach. Two approaches. Okay. Let's see the reduce and return approach. Okay? What is this approach? We are going to reduce the circuit into a simpler one. Okay? We can combine R3, R4. We do apply the series connection rule. Okay? Then we apply the parallel connection rule. And then we can apply the series connection rule again to determine R total. Voila? So here we can simplify this circuit to become we call it R dash, where R dash is equal to R3 plus R4. Well, then we can simplify this circuit to become R dash dash, where we combine R2 in parallel with R dash. You got the point? Okay. Then we can simplify this circuit into a reduced form where we have E in parallel with R total, where R total equals R1 plus R dash dash. You got the point now? We reduced the circuit into a simpler form. Okay? In order to determine IS. So we can determine IS, then we can determine I2, V4, V2, etc. Okay? So we have reduced the circuit. So what is IS? It is E divided by R total. Okay? What is V2? It is IS times R dash dash. which is the combination R2 in parallel with R dash. Yes? You got the point?
Yes.
Shabab? Okay? And by using the voltage divider rule, we can determine V4, it is R4 divided by R dash times V2. It is the voltage across R4, it is the total voltage V2 times R4 divided by R dash. Okay? So we have reduced the circuit into a simpler one, and then we can go back, we return we have reduced it, and then we can return to determine V4, to determine I2, to determine V2, etc. etc. You see? This approach, we call it the reduce and return approach. Okay? We have to reduce the circuit into simpler form. Okay? And then return back to the original form to determine whatever variables we have. Okay? This is the first approach. The second approach